For Chem 100, Exam 9, Chapter 18, we're going to do a review today in electrochemistry. Working from the review document that's hard copy here in Classroom or on Brightspace. And I've identified some problems that I want to be sure and get to. Highlighted those. So let's get going. Number 1. Consider the following reaction. Right? Barium and chlorine produces what? Barium chloride. Okay. Now, what's the question? Which of the following statements is true? All right. From an inspection of the questions, we're looking at gain and loss, oxidation reduction, obviously, since that's the chapter we're in. So I think to answer the question, first we ought to decide where the electron's going. Right? First, you have to identify the oxidation states for each of the elements. Right? For these elements, it's 0. Right? That's first rule. For this compound, chlorine would have to be, well, barium is an alkaline earth, so it's always 2+. And chlorine is a halogen, and when all else fails, give chlorine a -1. Okay, so now we can identify where the electrons went. From barium to here, how did we get from 0 to 2+? We had to lose 2 electrons. So we had a loss, 2 electrons per barium, times 1 barium equals 2 electrons total. Right? How about chlorine? Right. Chlorine would then have to be a gain. Remember? Oxidation and reduction always occur together. So we gain from here to here, we gain 1 electron. 1 electron per chlorine times 2 equals 2 electrons. And there we have the balance, right? Gain 2, lose 2. All right, so now let's answer the questions. E says none of these. So all we have to do is find one that's true. We don't have any 2 of the above or all of the above, those types of questions. So we just need to find the one that's true and we can stop. Barium atom is losing electrons. That's A. Yes, barium atom losing electrons. Therefore, it is oxidized. Right? Remember this? Oxidation is loss. So barium is oxidized. And reduction is gain. Okay. So chlorine is reduced. Well, actually, A looks like the best. Barium atom losing electrons, therefore it is oxidized. So I think A is our best choice. Right. Number 2. In the reaction, let's see, 2 calcium and 1 oxygen. 2 calcium, solid, and 1 oxygen gas yields what? Calcium oxide. 2 calcium oxide solid. All right. The calcium is oxidized, electrolyzed, synthesized, reduced. Okay. So what's happened to calcium? Well, we start with 0 and 0 here. This is a 2- and this is a 2+. So if we're looking just at calcium, What happened to calcium? And a loss of 2 electrons per calcium times 2 equals 2 electrons. Okay, since we're focused on calcium, we don't need to go any further. We just need to identify what happened to calcium. Calcium loss. Oxidation is loss. Right? So again, A is the best answer. Calcium is oxidized. It's not electrolyzed, it's not synthesized, it's definitely not reduced. All right, how about 3? Okay, in the reaction, strontium plus what? Fluorine gas yields, let's see, that's a solid. Okay, fluorine is what? Reduced, oxidized, galvanized, electrolyzed. So if we're looking at fluorine, what happened to fluorine? Well, it went from 0 to a -1. Right? So it gained 1 electron per fluorine times 2 equals 2 electrons. Right? So oxidation is loss, reduction is gain. Right? So fluorine is reduced, and that's A again. All right. All right, let's work with some compounds. Determine the oxidation states of each of the elements. Number 4. Okay, oxidation state of sulfur in K2SO3. We have 2 approaches to this. We know that SO3, sulfite, is a polyatomic ion. Right? This whole thing is a 2- charge, and this is a +1 charge. Right? So if we're looking for the sulfur, we could just take this one right here and say oxygen is a -2 times 3 is a -6. We have to keep a 2 out for that charge. That means sulfur has to be a +4. Okay, and A again. You can do it that way, or you can take the whole compound. Works both ways. About 5. 5, oxidation state of chlorine in lithium chloride. This is pretty simple. Lithium is an alkali metal, and they are always +1. So chlorine has to be a -1. Right? So that A is again. Kind of stuck on A here. All right, 6 and 7. We just keep going here. 6, oxidation state of carbon and carbon dioxide. These compounds were ionic. Right? So we could look for charge and assign oxidation numbers. But this is a covalent compound. So we have to go back to our rules. Oxygen in a covalent compound is -2. So if we've got 2 times 2 minus, we've got a -4 total. That means this one carbon has to be a +4. Okay, and that means the answer is A. About 7. Oxidation state of sulfur in sulfate. Okay, so now we're just given the polyatomic ion. Oxygen is -2 times 8 times 4 is -8. We have to hold 2 of these negatives out for the charge. So that means we only have to balance a -6. That means sulfur would be a +6, which is again A. All right. And we got a couple more. Number 9. And we're looking at H2CO3. What's that name? Well, if we assume that it's in an aqueous solution, if it's like this, then it's an acid. And this is a carbonate, polyatomic ion, H become X, right? And with oxygen in the name, you don't say hydro. You just take that name and say carbonic acid. Right? That's not the question. Oxidation state of carbon is what we're after. So in this case, this is a neutral compound. We could take this carbonate as CO3 2-, but let's do it the whole, let's take the whole compound and work it that way. So hydrogens are +1, oxygens are -2. So we have +2 here. We have 3 times -2 is -6. That means we have a -4 on the balance. That means that one carbon has to balance this -4. So it has to be a +4, which is A again. All right. How about 11? 11. Okay, the question here is the oxidation state of rubidium. If it just stopped there and said the oxidation state of rubidium is, then it would be 0. But it also says, the question also stipulates rubidium in a compound. Rubidium is an alkali metal, right? That means it's a +1. And that means also that our answer is B. Good. Let's go. Next one is 12. Okay. Oxidation state of oxygen in O2. Remember, an element in its most stable form at room temperature and pressure, standard temperature and pressure, is 0. So the oxidation state for each one of those oxygens is 0. All right. So the answer here is C. How about 15? Scroll down a little bit. Oxidation state of phosphorus in Mg3PO4, 2. Mg3PO4, 2. Okay. So magnesium is an alkaline earth. They're always +2. Right? So 3 times +2 is +6. How about over here? Well, oxygen is a -2, but how many oxygens do we have? We actually have 8 oxygens. Right? 2 times 4 is 8. 8 times 2 is 16. Right? So if you put those together, we have an imbalance of a -10. And that the positive charge balancing these +10 is distributed among 2 phosphorus atoms. So each one of those phosphorus has to be a +5. All right. That would be the answer D. How about, who's next? 17. All right. How about dichromate? Oxidation state of chromium. Cr2O7, 2-. Okay, oxygens are -2 times 7 is -14, and we need 2 minuses held out for that charge. So we only have to balance a -12. And a -12 balanced to a +12 with 2 chromiums, each one would have to be a +6. So the answer is B. Lots more practice there. We're going to skip over those for now. Okay. Let's see who's next. Number 28. 28. In reacting metal atoms characteristically what? Become anions, lose electrons, decrease oxidation state, form covalent bonds, two of the above. All right. So when a metal finds itself in a compound, it's usually a positive charge, either a plus 1, 2, 3, or 4, usually, sometimes more, but it's a positive charge. So it has to lose electrons, right? It has to increase oxidation number. What else can we say? It can be oxidized. Those are the possibilities that work for metals. So which one of those fits? Becomes an anion? Nope. That's a positive charge, not negative. Lose electrons? Yeah, that's right. So B is a possibility. Decrease oxidation state? No, it increases. So C is out. Form covalent bonds? No, metals do not form covalent bonds. Two of the above? No, just one. Just B. Next, 29. Which statement is true of the following reaction? Let's see, we have 2 potassium plus copper 2 chloride yields 2 potassium chloride plus copper. Okay, let's see, is that balanced? 2 potassiums, 1 copper, 2 chlorines. Yeah, we're good. Okay, now what? Copper is reduced, chlorine is reduced, potassium is reduced. Okay, reduction, oxidation, that's what we're looking for. Oh, I got an extra one down there. We'll deal with that red one in just a second. So if this is 0, of course, it's an element, 0. This is a -1. This is a +2. This is a +1, and this is a -1. Okay, so what happened to the potassium? What's the question? It's looking at all of them, so we got to do each one. So if we go potassium here, we have a loss of 1 electron per potassium times 1 equals 1 electron. Oops. My mistake. How many potassiums are there? There are 2. There we go. So that means 2 electrons. What happened to the chlorine? Nothing. Chlorine did not change at all. Copper did change. Right? Copper gained. Right? It went from 2 plus to 0, which means it gained 2 electrons per copper times 1 equals 2 electrons. Okay, now we can say something. Copper is reduced. Is that true? Copper gained electrons. Yes, it was reduced. Okay, so A is a possibility. Chlorine is reduced. No, nothing happened to chlorine. Potassium is reduced. Well, you can't have both of them reduced. Potassium is oxidized. And copper is oxidized. No, we already said copper is reduced. Right? So the only correct answer is A. Okay. How about the next one? That extra one that I threw in there. Okay. Copper 1 oxide plus H2SO4 sulfuric acid yields copper plus copper 2 sulfate plus water. All right. See, I need to make some room here, so let's erase this one. Yeah, that's good. Okay. So what happened? Well, let's see. Oxygen is -2 here, -2 here, -2 here, and -2 here. Nothing happened to the oxygens. Copper is +1 here. Right? -2, 2 times +1 balances. Hydrogens are +1. Sulfur then would be what? Well, let's see. -2 times 4 is -8. And then +2 is -6. So sulfur is +6. All right. Well, let's see. That's sulfur's in sulfate over here. It's +6 again. Right? So if this whole group is -2, right? That's sulfate. This one has to be a +2, and this one has to be a 0. So what happened? Well, we've got two coppers. One of them went this direction, and the other one went this direction. Okay. This, in the lecture, I identified this as a disproportionation. Reaction. Okay, that was getting a little weak. So what happened to the copper here? +1, 0, it had to gain 1 electron per copper, and only one of these coppers went. So it's 1 electron. The other copper went this way. It was a loss. 1 electron per copper. Right? And there's only 1 copper over there, so it's times 1 equals 1 electron. So we have copper goes 2 different directions. Okay. And that wasn't one of the questions in the review document, but I thought it was an interesting problem. Number 30. Which of the following does nitrogen have an oxidation state of +4? All right, so we got to do each one. A, B, C, D, and E. So we have nitric acid. We have nitrogen dioxide. We have dinitrogen monoxide. We have ammonium chloride. And we have sodium nitrite. All right. So what do we have here? Well, we have a -2 times 3 is -6. And then we have a +1, which is a -5. That means the nitrogen has to be a +5. Okay, that's not it. How about this one? Well, a 2- times 2 is -4. So this one has to be a +4 to balance it. Right, there you go. That's it. How about the rest of them? Let's just do them for fun. If this is -2, and you have 2 of them that needs a +2 balance, that means each one has to be a +1. Here we have, let's do the whole thing. -1, this is +4 total, so that's +3, this has to be a -3. And this one has to be a +1, this is a -2, So -4 and a +1 is -3. This is a +3. Okay. So the only correct one is B. It's interesting also that nitrogen can have so many different oxidation states. +3, -3, +1, +4, +5. Right? Nitrogen, carbon is like that also. Carbon can have anything from +4 to -4. All right. So let's scroll 34. Let's see, answer the question that refers to the following equation. Which species is the reducing agent? Okay, so we have titanium 4 chloride, which is a liquid. And we're reacting it with oxygen gas. Okay. And we're producing titanium 4 oxide, solid. Let's see. Yeah, and chlorine, gas, right? Okay. All right, which species is the reducing agent? All right, so we've got to go to the oxidation numbers first. That's 0. That's 0. This is a 2-. This is a 4+. This is a 1-. This is a 4+. Right? Okay. So what happens to the titanium? Nothing. What happens to the chlorine? Chlorine goes from a -1 to a 0. So how did it get there? It had to lose 1 electron. 1 electron per chlorine times 4 equals 4 electrons total. Oxygen went from here, 0 to 2-. Right? So we had a gain of 2 electrons. 2 electrons per oxygen times 2 equals 4 electrons. Okay? So, what is a reducing agent? A reducing agent is the species that is responsible for a reduction of the other one. So that means the reducing agent must be oxidized. Who was oxidized? Oxidized. That species right there was oxidized. It is the reducing agent because it caused the reduction of oxygen. Okay, so D is the answer. Oops, scroll. There we go. 38. In the reaction, phosphorus plus 10 chlorine. Phosphorus plus 10 chlorine gas yields what? Phosphorus pentachloride. 4 of them. And it's probably a solid. Phosphorus is what? Reduced, oxidized, electrolyzed, synthesized. You can just forget those. They have nothing to do with this problem. So it's either reduced or oxidized. Phosphorus. Phosphorus goes from 0 to what? Well, if this is -1, this has to be +5. Right? So in order for that to happen, we have to have a loss of 5 electrons per phosphorus. Times 4 equals 20 electrons. So a loss means oxidation is lost. So we have oxidized phosphorus. That's why D is the answer. Okay. Same problem, different question. 39. Okay, so the question now is what happened to chlorine? Well, chlorine went from 0 to -1. So we had a gain of 1 electron per chlorine times 10, right? 5. Let's see. No, 20. 2 times 10 is 20. Equals 20 electrons. There we go. So in that case, chlorine is reduced. Chlorine is reduced. That means B is the best answer. Okay. All right. 44. In the reaction, magnesium plus sulfuric acid. Magnesium plus H2SO4 yields magnesium sulfate and hydrogen gas. Okay. Which element, if any, is oxidized? Well, let's see. Oxidation state there is 0. There's 0. Right? Sulfate's the same on both sides. So sulfur and oxygen didn't change. We focused on hydrogen. So what's the oxidation state of hydrogen? 1 plus. Okay. So magnesium goes to there. Oh, we didn't do magnesium. So if this is a -2, this has to be a +2. By that calculation or by the rules, alkaline earths are +2. Right, so we had loss of 2 electrons per magnesium times 1 equals 2 electrons. And then hydrogen went from a +1 to a 0. So we have gain 1 electron per hydrogen times 2 hydrogens equals 2 electrons. Okay, so which one is oxidized? Oxidation is loss. So magnesium had to be oxidized. That means A is the answer. All right. Let's see if we can get them both on the same time. 48. Coming up. In the following reaction, which species is the reducing agent? The reducing agent is the species that is oxidized. So let's see what we got here. We got 3 coppers. And we've got 6 hydrogens, ions. And we have 2 HNO3 yields what? 3 copper 2 plus and 2 nitrogen monoxide, and the last one 4 waters. Notice there are no anions on this side. That's because the anion that would have been associated with this one is probably a spectator. But we do have a balancing charge anyway. 6 positives, 6 positives. But that's not looking underneath at the movement of electrons. So let's do there's copper. And this nitrate, this oxygen is a -2. So a -6 and a +1 from that hydrogen, -5. So we have a +5 here. And that's the hydrogen there is the charge plus. This is a -2, that means +2 here. This is a -2 and a +1. Okay. So what happened? Well, I can see copper did something, right? Copper went from here to a +2. That means it was a loss of 2 electrons per copper times 3 equals 6 electrons total. So loss means copper was oxidized. That means it is the reducing agent. Okay. Well, that's our answer. What's the reducing agent? Is copper. Right there. If we were to look at the rest of them, what happened to nitrogen? Oxygen didn't change, but nitrogen did. Nitrogen went from here to here, which means a gain of 3 electrons per nitrogen times 2 equals 6 electrons. Because there are 2 nitrogens here, 2 nitrogens there. All right, but the question we answered is B, copper. Let's see, 49. We're going to balance an equation using the oxidation state method. Okay. What do we want? Determine the coefficient for the iodide ion. All right. So we're starting off with dichromate. Let's see, 49. 49. Starting off with dichromate plus iodine. They're all in aqueous, except for iodine on the product side is solid. I don't think it'll affect our balancing procedure in this case. Okay, so what do we do first? Well, we have to split the reaction into oxidation step and reduction step. That means we have to know what the oxidation states are. That one's -1, 3 plus, 0. -2 times 7 is -14, hold 2 out is -12, plus 12 divided between 2 is +6. Okay. All right. So the oxidation step would be iodine would lose an electron to go to 0. That's the oxidation step. So we're going from iodine to iodide ion to iodine. Okay. How about the reduction step? Well, that's what's left over. Cr2O7, 2 minus here. This is +6. And this is 3 plus. Okay. Now we balance anything that's not oxygen or hydrogen. We have 2 iodines over there. We need 2 here. We have 2 chromiums here. We need 2 chromiums there. Okay. Now we balance the oxygens. We're going to do this in acidic solution. The question asks us to do this in acidic solution. So we're going to add 7 oxygens on this side as water. That means we've added 14 hydrogens. So we're going to put 14 hydrogen ions on this side to balance those. Now we'll do the electrons. Okay. If we went from 1 electron here to 0 there, we lost 1 electron, but we have 2 here. So that means we have 2 electrons over there, separated from the iodine. In this case, we went from +6 to 3+. That means for each chromium, the chromium gained 3 electrons, but there are 2 chromiums. So that means we have 6 electrons gained to go from these 2 to those 2. Okay, now we balance the electrons. All we have to do is multiply this one times 3. Right? That gives us 6 electrons. That gives us also 3 iodines, and that gives us 6 here. Okay, now we can add them together. Now, we don't have to add the whole thing together to answer the question, because the question says, what's the coefficient in front of iodide ion? Right here. Well, we know coefficient is 6, right? So the answer is D. But if we were to add these together, what would we get? Cr2O7, 2 minus, plus 14 hydrogens. The electrons are going to cancel, so we don't have to bring those down. And then we have 6 iodides. Right? That covers 1, 2, 3, 1, 2, 3. And on this side, we have 2 chromium 3 plus 7 water, plus 3 iodine molecules. Okay. Now, is there anything we can cancel? No, they're all unique. Right? So there's your final equation, your balanced equation. If the question had been, what's the coefficient in front of the chromium 3 plus ion? That would be 2. Right? So the question could go, rather than iodine, right? If you just memorize the answer as iodine and put that down, maybe the question changed. Maybe the question says, what's the coefficient in front of the hydrogen ions? Right? 14. That means I'd have to change the answers, of course. All right, here are other questions that could, see, there's the chromium 3 plus, right? There's the coefficient for water, that would be 7. Now let's look at 52. Okay, for the reaction of sodium bromide with chlorine gas, sodium bromide with chlorine gas, okay, to form sodium chloride and bromine. Let's see, yes, bromine. The appropriate half reactions are, okay, so we have to do oxidation states first, minus, plus, minus, plus, and they've got them in order of oxidation, then reduction. So oxidation first, reduction second. So what was oxidized? What lost electrons? Well, it looks like bromine. Bromine went from a -1 to a 0. So the oxidation step would include this one, yields that one, And that means the reduction step would be this one yields this one. Okay. Let's see. Oh, okay. So we're going to use only the ions, right? See, by looking at the answers, we see what the question really wants from us. So since sodium is just a spectator, we're going to say that sodium is gone. And this sodium is gone. So that means this is an ion, and this is an ion. Okay. Now we'll do our balancing routine. We need two of these. We need two of these. We're going from a -1 to a 0. So that means we have to lose 2 electrons, right? 1 electron each times 2 is 2 electrons. That means we have to add 2 electrons to this side. Okay, so there are oxidation reduction reactions. So it looks like, let's see, B. Yeah, B is the best choice. All right, that's 52. Scroll some more. 56. Use the other side. 56. When the following reaction is balanced in acidic solution, what's the coefficient of water? All right, so we're going to do the same thing we did before, only with a different equation. We got zinc, solid, plus nitrate ion, aqueous, and we get zinc, 2+ ion, plus ammonium. Okay. So oxidation states 0, 2+. This is 3 times 2 minus is -6. Keep 1 out, -5, +5. Right? 2+. This is +1 times 4 is 4+, but we have to hold 1 out for that plus. 3+ means 3- for that nitrogen. Okay, what happened? Well, what's the oxidation step? The oxidation step is loss of electrons. Zinc lost 2 electrons. So we got zinc, solid, goes to zinc 2+ ion. Okay? That means the reduction step has to be, 3-, this is a +5, and it went to ammonia. Excuse me, ammonium at a 3-. So yeah, we did gain electrons. Okay, 1 zinc, no problem. 1 nitrogen, no problem. Now we go to balance the oxygens. No oxygens here to balance. Oxygen there, yes. We have 3 oxygens. So we have 3 waters, gives us 3 oxygens. Now we have 6 hydrogens. Okay. Next, we do electrons. So how do we get from here to here? We have to lose 2 electrons. And on this side, we have to gain how many? +5 to 0 means we gained 5 electrons. And then to 3-, we gained 3 more. So we had to gain 8 electrons. Okay. Now, balance the electrons. Well, all we need here is a 4. Right? A 4 times 2 is 8. And then a 4 here and a 4 there. Okay. So we're asked to what is the coefficient of water? Well, let's see. We've only got water on one side. And we've already balanced the electrons. Right? So the coefficient in front of water is 3. Okay. We can add them all together, but we've answered the question. Let's see. Okay, now we're going to talk about a battery, a galvanic cell. Right? That would be number 58. Which of the following is true for a galvanic cell based on the following reaction? All right, we got zinc. And we've got copper. Okay. Yields zinc 2 plus copper metal. All right. So let's see. This is 0. This is 0. And if we go from this zinc to that zinc, that means we have lost 2 electrons per zinc times 1 equals 2 electrons. And the copper has gained 2 electrons per copper times 1 equals 2 electrons. So what's happened? Well, oxidation is lost. So this one is oxidized. And this copper has gained, so it is reduced. All right. Okay. Let's identify, since this is a galvanic cell, we've got some names. So what happens at the cathode? The cathode is the site of reduction. So this would be the cathode. In other words, the cathode would involve that copper ion and this copper there. So that's actually, this is the anode. And this is the cathode. Oh, excuse me. The site of reduction is the cathode. There you go. And this is the anode. Okay. All right, now let's see which questions match. The zinc is being reduced. Zinc, no, it's oxidized. The zinc serves as the anode. Yes. So B is true. Copper 2 plus ion is being reduced. Copper 2 plus, yes. So C is also a possibility. How about D? The copper serves as the anode. No. Copper serves as the cathode. So 2 of the above, actually. E would be the correct answer. All right. Number 60. In a car battery, which of the following is the electrolyte? The electrolyte is the solution into which the electrodes are submerged. And in a car battery, the electrolyte for the anode and the electrolyte for the cathode are exactly the same solutions, sulfuric acid. So that's why D is the best answer there. I'm not sure why I added that statement and misspelled battery. Cell phone. Let's see. Maybe I can correct it. Let's see. Here. Here we go. All right, let's save it. All right. The electrolyte in a lithium ion battery, I don't think that's lithium ion. Lithium ion is part of the reaction, but it's not the electrolyte. So I'm not sure why I put that in there. Let's just ignore it for now. All right, in the lead storage battery, PbO2 is found at the what? All right, we have to look at what happens, that's 61. What happens to PbO2? Well, it's best if you know the end product. The end product is PbSO4. Okay, so that means this is +4 and this is +2. That means we have reduced this lead, which means that this is the cathode. Okay. A would be the answer. Cathode. This would be the reduction step. The oxidation step would take lead and go to lead sulfate, which is 2 + 0. Oxidized lead there, and that would be the anode. Okay. 61 and 63. Let's scroll a little bit here. When a metal corrodes, what is happening chemically? When a metal corrodes, it's going from 0 to some other charge. Right. +1, +2, +3, whatever. So what does that mean? That means it's losing electrons and it's being oxidized. The metal is being oxidized. It's losing electrons. So the metal atom loses electrons. Yeah, that's true. Are there choices? Well, it can't gain electrons too at the same time. Electrons are not involved. No, that's false. The metal is combining with nitrogen gas. I don't think so either. All right, so A is the answer. Okay. 66. Let's see. Balance the following redox equation in acidic solution. Okay. What's the coefficient of water? And then 67 uses the same equation, coefficient of hydrogen. Are we going to get one? I'm looking for one that's balanced in basic solution. Yes. Okay. We're going to get one in basic solution. So let's go back to 66. This one's going to be an acidic solution. So we got CH3OH, which is methanol. Right? Methanol. That's the one you can't drink. Plus dichromate yields CH2O. CH2O. I think that's formaldehyde. There we go. Okay, so if we want the coefficient of water, notice there's no water in that reaction. That means you've got to balance it by our redox method. So the oxidation step, reduction step, we have to know, this is +6, I'm pretty sure. Let's recalculate it. 7 times 2 minus is -14. Hold 2 out, -12. Yeah, +6. Okay. That chromium is 3+. This oxygen is 2 minus, and that's a +1. So +2 and 2 minus 0. That carbon is 0. Oxidation state. How about this one? Well, let's see. There's a +1, there's a +1, there's a -2, -2. So we have 3 + 1 -2. So it's +2. This is a -2. Okay. Now what happened? Well, chromium lost electrons, gained electrons, excuse me, 6+ to 3+. So we had gain 3 electrons per chromium. All right. And carbon lost 2 electrons. Lost 2 electrons per carbon. Okay. That's all we need to do now to decide which one goes where. So the oxidation step is the loss of electrons. You got CH3OH with a -2 here. And it went to CH2O with the 0 there. And then the reduction step would be the dichromate with a +6 there, and went to chromium 3+ here. Okay, so balance the non-oxygen, non-hydrogens. We got 1 carbon, we're good. 2 chromiums, we need 2 chromiums. Now balance the oxygens. Well, we got 1 oxygen here, and we've got 1 oxygen there. We don't need any water. Oxygens are balanced. But how many hydrogens do we have? Well, we've got 4 hydrogens here and only 2 here. So we need to add 2 more hydrogens, right? 2 + 2 is 4. 1 + 3 is 4. And the oxygens are already balanced. On this one, we have, let's see, 7 oxygens. So we need 7 waters. That means we need 14 hydrogens on this side. Now we can do electrons. This carbon went from -2 to 0, right? -2 to 0, loss of 2 electrons per carbon. So that means the electrons have to be on this side because that carbon lost them. Okay, on this side, we have to gain electrons. How many though? Well, let's see. We have +6 to 3+. Okay, +6, 3 electrons per chromium, but there are 2 chromiums. So there's 6 electrons there. Okay. So now we need to balance the electrons. All we need is 3 times 3 there, 3 there, 6 there, 6 there. So now the electrons are balanced. Okay. Now, the question was, what's the coefficient in front of water? Okay. We've got water where? Only here, right? So 7 is the coefficient of water, right there. E is the answer. Okay. What if we had said the coefficient of hydrogen ions? Well, we got 6 hydrogens there and 14 here. So if we use up all those 6s on this side, that leaves 8. So it'd be 8 hydrogens. Okay. All right, that was 66. Okay, 70. How many electrons are transferred during this reaction? All right, so we have gold chloride -1. This is a complex ion. With a -1 charge for the whole ion, for the whole group. And then copper, right? And we go to gold, solid, plus chloride ion, plus copper ions, right? Copper 2+ ions. All right, and this is aqueous. Okay, how many electrons are transferred during the reaction? Right, so that's a 0, that's a 0, that's a 2+, that's a 1-. How about inside here? Well, we have to go with a -1 for the chlorines. So that's 4 minuses and hold 1 out for the total. 3 minuses, that means 3 pluses for that gold. Okay, so what happens to the gold? Let's do it first. The gold gained 3 electrons per gold. All right. And we've got 1 gold here and 1 gold there. We got 4 chlorines here and 1 chlorine there. Right. But nothing happened to the chlorines, so we can ignore them. But copper did change. Copper went from here to here. Right? So copper lost 2 electrons per copper. But notice, copper lost 2 electrons, gold gained 3 electrons. So how do we reconcile that one? Right? The best way is to cross multiply. Take that 3, 6 electrons, and take that 2, 6 electrons. Okay. So that means with this 2, we need a 2 here. That means we need an 8 here, and we need a 2 there. And the coppers, we need 3. So that would balance the equation. And since we don't have any oxygens or waters in here, we can do it that way. This is the quick and dirty way. But we balance the electrons. That's the important thing. And there are 6 electrons that were transferred in this process. Now, if you feel more comfortable, you can break this apart into oxidation reduction and then balance the equation, put them back together, and you'll get the same answer. How about 71? How many electrons are transferred there? I think we can do that right down here. I say our equation is 10 plus 2 hydrochloric acid yields 10 chloride, yes, plus hydrogen. Okay, let's see, it's supposed to be balanced. Let's see if it is. 1 there, two hydrogens, two chlorines. Okay, that's balanced. Now, oxidation states 0, 0, 1 minus means two pluses and 1 minus and a plus there. Okay, so what happened to 10? 10 lost 2 electrons per 10 times 1 equals 2 electrons. Let's see if that holds. What happened here? Well, the hydrogen, chlorine stayed the same. And we got 2 chlorines, so we're good. This hydrogen went from +1 to 0, which means it had to gain 1 electron per hydrogen, but there are 2 electrons, 2 hydrogens equals 2 electrons. So the electrons are balanced too. Okay. So in this case, 2 electrons were transferred. Oh, there's an error. Yeah, that needs to come down to E. Not enough information. I don't know if I can fix that in, I can't fix that in the Acrobat. 75. In an acid dry cell battery for which the reaction is this, what is oxidized? Okay. And a note, identify all the players. Okay, let's see. Zinc plus ammonium chloride. And then plus manganese for oxide. Okay. Yields zinc 2 chloride plus ammonia plus Mn2O3, Mn2O. Oops. Try that again. I'm going to run out of room. Mn2O3 plus what? Plus water. That clears your water. Okay, what happened? Well, let's see. Oxidation states 0, 2 minus. This is -1, and chlorine, that's -1. So chlorine didn't change. Hydrogens, +1, and +1, +1, -2, -2. Oxygens didn't change. Hydrogens didn't change. Manganese. How about manganese? What's the manganese here? Well, let's see. This is a 2 minus, so it's a -4. Has to be a +4. And this manganese went from, let's see, -6 total for the oxygen. And we have to have a +6 here, so this is +3. So manganese did change. All right. How about nitrogens? Well, let's see. We've got +4 and a -1 means +3. This is a -3. And this is 3 times 1 is +3. Is that right? Hold on a second. -1 +4. -1 +4. +3 -3. -3 +4 is +1. Yeah, that's right. And this one is a +1 for hydrogen times 3 is +3, but we've got to hold 1 out. So it's +2. This is a -2. So nitrogen changed also. All right. Okay. So what happened to zinc? Let's do zinc first. Okay, zinc had a gain of 2 electrons per zinc. Okay, how about nitrogen? Let's see, nitrogen here to here. And nitrogen went from -3 to -2, which is a loss of 1 electron per nitrogen. And then manganese was also, now manganese gained electrons, +4 to +3. Yeah. Just checking my math. Yeah, okay. So it had to gain 1 electron per manganese. All right. So in this dry cell battery, we've got one that's lost, right? This is oxidized. This is reduced. And this is reduced. Okay. What is oxidized? Okay, we skirted the problem. Reduced, oxidized. Ammonium chloride was oxidized. Excuse me. Oxidized. Oh. Boy, that was a boo-boo, a huge boo-boo. That's a loss. So zinc was oxidized. Now, ammonia was oxidized also. Well, it's oxidized zinc, ammonium chloride, and ammonia. Oh, my mistake. That's a +1, it's a +3, -3. No, nothing happened to the nitrogen. My mistake. Nitrogen is fine. It's the same for both. Okay. So now we have this one's oxidized, this one's reduced. So the one that was oxidized was zinc. And if we go to the next question, it says, what atom is reduced? Well, the one that was reduced was manganese. Okay. Let's see. Here we go. When the equation for the following reaction is in basic solution is balanced, what's the sum of the coefficients? All right. So now we get to do one in basic solution. '83. We're starting with MnO2, HO2 minus yields MnO4 minus. Okay, what is that? It's probably a peroxide ion. More than likely. Okay. Well, actually, that's important. So let's see, manganese is going from, let's see, 2 2 times -2 is -4, so this is a +4. And this manganese is -2 times 4, -8. And we only have to balance a -7, so that's +7. And what do we got here? Well, if this is a peroxide, then each one of those oxygens is -1, -2 total, hold one out, +1. Okay? So each one of these oxygens is a -1. All right. So let's look at oxidation reduction. Oxidation reduction. Okay. +4 to +7 is oxidized. So MnO2, right, is going to MnO4 minus, and the +7 there. So what's being reduced? Well, the only thing left is this one. Right? The only thing left is HO2 minus. But what's it reduced to? Well, the only thing we have available to us is water. Right? So we're going to put the water in there in just a minute. First, we have to balance the manganese. Well, the manganese is the same on both sides. So now we can go to the waters. We have 2 oxygens here, 4 here. That means we need 2 there and 4 hydrogens here. So if we balance the oxygens here, we need 2H2O. And that means we need 4 hydrogens. Right? So 1 plus these is 3. Now, what has happened is this has gone from a -1 to a -2. Okay? Now we can do electrons. Right? We go from +4 to +7 means we lose 3 electrons for each manganese. So we need 3 electrons over here. In this one, we've gone from a -1 to a -2. We gain electrons, 1 electron per oxygen, but we got 2 of them. So we gain 2. I think that's the trick to this whole problem, is recognizing that that oxygen is only a -1 charge. Okay. Now we can balance the electrons. We got 3 there and 2 here, so we need cross multiply. Okay, so that gives us 6 electrons here. That gives us 6 here. And then 2, 4, 2, 8. Okay. And 3 times, we already did that one. 3 times 3 is 9. 3 times nothing is 3, or 3 times 1 is 3. 3 times 2 is 6. Okay. All right. So 6 electrons get canceled. I'm just going to bring the whole thing down. 2 MnO2 plus 4 water, and then plus 9 hydrogens plus 3 peroxide ions. Then we have 2 MnO4 minus, and we have plus 8 hydrogens, and we have plus 6 H2O. Okay. Now, that's an acidic solution. We need a basic solution. So we could cancel the waters now, but I'm going to wait. Let's get rid of these hydrogens. 8 hydroxyls plus 8 hydroxyls. Okay, this becomes 8 waters plus 6 waters is 14. And we have 4 waters here. So 4 from 14 is 10. Minus 4 equals 10 waters. Right? 8 plus 6. So we got rid of that one. We got rid of this one. And we're left with 10 waters on that side. And 8 hydroxyls on this side. Oh, I'm not finished. Hold on. Back up. Start over again. I just saw a problem. 6 waters, 8 hydrogens. 8 hydrogens. 6 waters. We've got hydrogens on both sides. Right. So let's get rid of these hydrogens. Now we're left with just 1. Okay. Right. We still got these 4 waters. There. All right, we got rid of those hydrogens. That one. That one. Okay, we're good. Okay, so now we're just going to get rid of this 1. Hydroxyl makes 1 water, and then a hydroxyl on this side. No, we got rid of those already. Sorry. Those are gone. So we got a hydroxyl on both sides. Okay. That makes a water here and 6 waters over there. So water here plus these 4, that's 5 waters. 6 waters on that side. All of these waters are gone. And we only have 1 left over here. Okay, so now we have MnO2, 2 MnO2s, 3 peroxide ions, 2 MnO4 ions, plus 1 hydroxyl, plus 1 water. So, when we add up the coefficients, what do we have? Well, let's see. 2 plus 3 is 5, plus 2, plus 1, plus 1. So that's 7, 8, 9. Right? D. The sum of all the coefficients is 9. Whenever you see one of these sitting by itself, it's always a number 1 coefficient. So don't forget to add that one in. Or don't forget to add that one in. All right. That was a difficult problem. The first encounter was, what's the oxidation state on oxygen? This is a peroxide, so that one has to be -1. That was the first trick. The second trick was keeping track of all the hydrogens and the waters. All right. Let's see. Got any more? 85. Basic solution. 85. We're starting with silver plus copper. And then we get silver metal plus copper 2 plus. Yeah, 2 plus. Okay. All right. When the equation is balanced, in basic solution, when the equation is balanced, the sum of the coefficients is. All right. Let me let you in on a little secret. There are no hydrogens in this reaction. There are no oxygens in this reaction. It doesn't matter. Acidic, basic solutions, it's the same both ways. So we don't have to deal with that. All we have to do is balance the electrons. Right? If we're going from +1 to 0, what is that? That's a gain. 1 electron per silver. Copper is going from this side to that side. This is a loss. 2 electrons per copper. So if our electrons are going to balance, we've got 2 electrons going this way. We need 2 electrons going this way, times 2. So we need a 2 here and a 2 there. So if we add up the coefficients, it's 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. 6 electrons, or 6 coefficients, excuse me. 6 is the total for coefficients, and that would be C. All right. And that's it. Those are the only ones I had identified. So I'm gonna stop the share, and we're about a half hour early. So this is Tuesday, the 23rd. The exam on this one will be due Thursday. Yeah. Let me mark this off of my schedule. Thursday, exam April 25th, exam on this material. And since this is the last chapter, I won't introduce any new material. What I will do is I'll open up Zoom on Thursday to see if anybody has any questions, and I'll stay up for about a half hour. And if nobody zooms in with questions, then I'll assume that everybody's okay and they don't need my input for taking the exam. Then what we'll do is the next week is the week before finals. We'll use both Tuesday and Thursday to review material for the comprehensive final. That will come on May the 7th. Deadline May the 7th. Okay. And in that case, for that final day, I will be here for anyone who wants to take the exam in person. And I'll stay for about a half hour. If nobody shows up, then I'll pack up and that'll be the end of the semester. Okay. That's it for today.